Okay, our next speaker is Douglas Nowacek, and he will be speaking on seismic surveys and marine wildlife impacts, the lack thereof, and thoughts on managing both.
Great. Well, thank you very much. Thanks to the organizers, Lily, Christine. Thanks for the invitation. You know, I'm absolutely delighted to be here and also to be a guinea pig. Apparently, test subjects, I think was what it was called, but I think we're guinea pigs. Okay, so I really want to do three things today, and that is to, in the context of marine seismic surveys, which exist for research as well as for siting oil and gas, and also for renewables in shallower waters typically. But three things. One is that we, you know, the animal bioacoustics community, there's pretty good agreement that certainly for certain species and animals, there are measurable impacts of noise sources in general, but certainly of seismic surveys. It doesn't apply to all species. It doesn't apply in all situations. That's part of the hard part of the management bit. So point number one, demonstrated we have effects. We need to sort out when and where. And it's also really important to think about turtles and fish. Next is on the management of these things and the mitigation of those. There are lots of options that are not really explored very well, in my opinion, in all cases certainly. But I'm going to run through a couple of those. So we have lots of options for mitigating and reducing the impact of those surveys. Part of that management is also the evolution of some nice tools, and I'll give a couple demonstrations, a couple examples of those, and how we can effectively bring into the equation, the management equation of how it's affecting the animals, including the feedback, which is really important. And then the last thing I'll spend a couple slides on is talking about the next generation of managed ocean noise. And we have one idea that we recently published, but then I also wanted to talk about a potential call for standardization through the standards process. Okay, so on the impact side, I'm going to move through these pretty quickly. Folks are certainly welcome to go read the papers, and I'll send you the quiz on email. This is certainly worth spending a minute on, and that is a review paper, a wonderful review paper that came out this year on this 2 decades of research on the impact of noise on wildlife. There are some 300 studies reviewed in this paper. 2/3 or 3/4 of which, somewhere in there, came from birds and marine mammals, and they came to conclusions of things like demonstrated fitness impacts, which are a really important measure of the impact, and then also effects on ecological communities. So we know there are the potential for the effects. Now I want to give a couple of quick examples of individual marine mammal species, and I'm, again, not going to spend a lot of time on them, but suffice to say that there are different interpretations of the data, but one of them is certainly that we're seeing an effect. This is from set of experiments in the Gulf of Mexico. What you see on the y-axis is the buzz rate of sperm whales, and the buzz is the terminal phase of foraging. So we use this as a proxy for foraging rate. What we see across the x-axis is proximity to the air gun survey. And what we see is a slow decline or measurable decline in buzz rate as the air gun array gets closer. So these are the kind of things that we are concerned about. Does it interrupt foraging for an animal? In this instance, yes. Not in all instances. Another example, humpbacks. Again, without giving you too much context, I'm sorry, but what we have on the x-axis here is the received levels, and on the y-axis is the number of singers. And so what we see as the received level at the animal's locations increases, what we see is a decrease in the singing of humpbacks, in this case in the Mediterranean. Okay, another example, and this one is an excellent synthesis of data from the Arctic from many, many years of research on bowheads. This is the Blackwell et al. Paper from this year. This is really interesting biologically and ecologically to me, because what we see, and you'll see the C-SEL measurements across the x-axis, and at very low levels, in the 90s dBs, that we start to see a vocal response by bowhead whales. In this case, they start to increase their calling rate. It plateaus for some period of time, and then it starts to drop off. And I want to point out one thing, and that is this number out here, 160, and it's a little hard because it's in SEL, and what I'm going to talk about later is in RMS. But we see them start to give up, essentially, and the calling rate drops off. So one of the interpretations of this biologically is that they've gotten to a point where the noise is loud enough that they've made the decision, okay, I'm just going to wait for the noise. I'm going to wait it out, and I'm not going to try to call anymore because it's not effective to get through that channel. Okay, this table, don't scrutinize it too much. There are several examples of known impacts. There are also things like for fish that we see no long-term effects. the point is that we have a good body of evidence to talk about what those impacts are. They're not universal, and they need to be managed as such. Okay, a little bit about on tools and how to approach these problems of seismic surveys going off and what the receive levels are like at various places. The good folks at JASCO and Roberto Rocca lent me these slides. This is off the coast of Nova Scotia, and it's very hard to point with this with the sensitivity of that. So there's these sites that they wanted to estimate the source, the receive level. Here it is. It's in a canyon, and so they're doing a great job modeling the canyon. These are really where the rubber meets the road. These are the SEL measurements, and you can see just in the very top corner of each of the 4 panes is where that site was. And so you see the difference in the propagation, which shouldn't surprise any of us in this room. But the fact is that animals up on the shelf, in this case down here in the lower right figure, are going to get a much different dose than animals in the gully itself. And this is a very important tool for the cumulative, and this is, if you look across the bottom, modeled acoustic field, unweighted in this case, for the SEL integrated over 24 hours. So the seismic surveys can go on for days at a time, 24/7, for days and days and days. Okay, so we really need to be thinking in terms of these long-term integrated measurements. Okay, a couple more tools. This out of the Cornell lab, and this is just a quick orientation. There's a seismic survey vessel that is plotted here, and there's a whale at 10 miles and a whale at 50 miles. And across the bottom, we see the instantaneous SEL as those acoustic pulses go out. And again, a lot of my point here is that we have tools that we can use to bring to issues like standards discussions and long-term impacts, long-term potential impacts. Okay, and then moving from that into I should say, when you look at this, and I won't let the whole thing run again, one of the things to notice is that the reverberant energy that remains between pulses that is partially the data that the seismic surveys are after, but part of it hangs around. And this is some data from Baffin Bay, again, courtesy of Chris's lab. The initial shots are in the pluses and symbols at the top. Lower are the number of seconds after the direct pulse. And so what we see is that the background noise level is sufficiently elevated during the survey in that area. Again, getting to what is the total dose that the animals are getting. Okay, this is a static diagram, and I will tell you why I'm being redundant. So we're seeing basically the same setup we saw in that little movie, with the source at the center and then the 2 animals at 10 and 50 miles, in this case off Virginia Beach. One of the reasons that this is a hot topic is because there's a lot of discussion in the Atlantic right now about potential for seismic surveys. And then so we see the lighter blues in between the pulses of that remaining reverberant energy, and that's just 5 seconds later. And you can see that now even that farther animal is at a somewhat elevated level after the pulse goes by. Okay, so what do we do with information like this? This is one application of it. This is part of the tool, I would say, in trying to get a handle on impacts and whether they're a problem or not. This is some data out of the Marine Geospatial Ecology Lab at my own institution at Duke, Pat Halpin's lab, Jason Roberts. But this is just to give you an idea of one of the reasons this is a hot topic in the Atlantic. This is right off Cape Hatteras. It's right at the shelf break. It's a very interesting area oceanographically, biologically, but it is the most, what you're seeing in these cells is a species richness in just cetaceans, just the whales and dolphins. And so it is, as far as we know, the most diverse and rich area in the Northwest Atlantic. And it's right at the crosshairs of where a lot of the seismic surveys are proposed. And so we have this nexus of use, and this is one of the ways we can measure it. So we can take data like this, put it on those maps that I just showed you, and get an idea for what sort of impact we may be able to measure. Okay, so we thought about this a little bit, written a couple papers. This mainly came out of some efforts working off Sakhalin Island in Russia with the International Union for the Conservation of Nature. This paper has folks from industry, from private sector consulting, from academia, from government. So trying to really think about this holistically as we can to come up with some ideas for how to best manage these things. And I'll come back to a little bit of this paper. The more recent one is this one, and this is where we've proposed some ways forward and thinking about how do we move into we're in the 21st century. We know these things cause impacts in some cases, and how do we appropriately manage those without over-regulating anybody? Okay, This is a, just to show you that I can make cool, colorful pictures. Apparently, this is part of the process that we envisioned in that responsible practices paper, is that there really is a process to this. And the last one, maybe being even the most important, is after you do analysis of your mitigation and monitoring measures, is that you do those analyses and get those back into the process so it can be updated and updated appropriately, right? We need less mitigation because there were no animals there. We need more because animals ran away. Whatever the conclusion is, that it gets fed back into the system. Okay, so I promised, and I'm sure you're all on tenterhooks waiting, lots of mitigation measures that aren't talked about really in the current round of, at least in the Atlantic, the incidental harassment authorizations and so on, that and that's partly historic and it's nobody's fault. It's just the way it is, and I think there's not quite enough creative thinking. The picture over here is from Sakhalin. This is the theater we came up with for monitoring and mitigating impacts to western gray whales that like to feed right along the coast, and there's lots of oil and gas under that shelf, and so we came up with a very elaborate, this is a perimeter monitoring line, so we can hear what the whales are actually hearing. We have scout boats making sure there's no animals in the direct path and so on, so there's lots of things. But I'm not going to go through all these. I'll come back to some of them, like exposure criteria, acoustic monitoring, but there are lots of options open to getting a handle on how to better manage these things. The last one, alternative sources, I'll come to now. There are some viable sources coming online, and this is a relatively old, it's from 2005. This is PGS's marine vibroseis unit, and the idea with the vibroseis is that it produces a much narrower band signal. In general, the seismic work, be it research or offshore energy, is really interested in the low frequencies, really below 100 and 120 hertz. And so what you see in the before and after picture is what the marine vibrator source has been able to do in cutting out those harmonics. And these are, responsible for a lot of the received energy that whales are receiving. There's certainly whales that are sensitive down to these lower frequencies, but again, that's part of, there's no perfect source. You need to put energy in the water to get into the bottom to find out where the faults are, where the oil is, where not to put your wind turbines. But nonetheless, if you don't need this, and it's great to hear some of the Danes and folks talk about this energy up here, they say it's not efficient. We don't need it, so let's not make it. So that's be efficient about how you put that energy into the water. Okay, so the last bit that I'll spend a few slides on, because I'm really interested in folks' thoughts and feedback on how best to move along. First of all, one of the main things that we need to talk about is for appropriate impact thresholds. Currently in the U.S., this is managed as 160 dB for a behavioral response, be that a change in vocalization patterns, change in migration, a change in foraging rates, as I've shown you, for behavioral disruption. But remember what I pointed out, that 160 on that plot of bowheads, and we're only catching the tail end of that response. That response started long before then. So we need to move, we need to figure out where those criteria, those impact thresholds should actually sit. And it's not a simple issue because of differences in the species, but then also differences in what they're doing. Right now, the exposure is managed so that nobody gets over 180 for injury, which I think is a very rare event, if ever, because there's some good methods undertaken to not let that happen. The revisions to impact criteria are underway. There was Brandon Southall and company wrote a paper in 2007 about some initial criteria. We're actually in the midst of revising those and working on those more. And so there are several efforts underway to do this. And really a single number for, if I played an annoying sound to all of you, some of you get much more annoyed more quickly than others, right? Depends on your hearing thresholds, your hearing capability. So if I played something high frequency, the young people would run. So we need a risk function is much more appropriate, and there are some of those things underway too. I'll also call out the need for more baseline data. One of that in the planning and assessment of the potential impact of any activity that you're going to have. Not least of all is some acoustic one in the ocean, but understanding what's in the area, their sensitivities, and how you fold that into the system is important. And then finally, cumulative effects. This is a hotly debated topic in and of itself. In a very long environmental impact statement from from the Bureau of Ocean Energy Management was certainly acknowledged, but there was very little in the way of, and it's not BOEM's fault, the tools are not quite as far along, I would say, but we are coming, and I've listed a couple of them. There are some real pragmatic challenges to how do we deal with cumulative effects. But if you think about all yourself sitting in a room, right, a lot of the ASA talks about is architectural acoustics and thresholds and levels that are permitted for humans. And same thing goes for these guys, that there are going to be long-term impacts if we don't manage them. Okay, so there are the PCOD is the population consequences of disturbance, and so this is a model that tries to bring in many factors into a model that tries to estimate the potential for long-term impacts. Estimating masking, we do worry a lot about masking. Great, and there's some progress there too. Okay, so how do we move forward? When we wrote the most recent paper, I really got curious about how things like noise that move through the ocean. The nice part about noise is when you turn it off, it stops, after a few minutes or seconds. But turns out that transboundary air pollution is an interesting analog, right? Because it's a point source and it spreads downstream, whatever that stream happens to be. Along those lines, in terms of in the ocean, the European Union, and this is this list here, CBD, Conservation of Migratory Species, UNCLOS, the UN law, the sea, which the US hasn't signed, but lots of other people have, all recognize energy discharge, including noise, as a potential problem for wildlife. And so we can manage it and we can take advantage of that because there's structure in place to actually do that, and that's one of the things that we talk about. There are certainly standards committees on other noise sources, including underwater noise sources, and I'm going to come to that at the end. Okay, so what were our options? How do we move forward? We have a bunch of information, and how do we assemble it and put it all together and put it to good use? We could come up with a new convention regulating all non-military noise sources, which seems unlikely. IMO under MARPOL, the definition of harmful substances or discharge could actually be a legal route that we explored with a couple of lawyers on the author list. But then certainly one that I would like to explore and have started to explore at this meeting is a new animal bioacoustics working group with ocean acoustics and noise. And perhaps a receiver-based standard would be interesting, because then we take out the issue of the noise source type, which is probably more realistic for the animals. Okay, a few things here. I'm not going to read through all these. We talked about what to include in that, and that can certainly go into the standards discussion or into an IMO. But one of the things I want to really conclude at is moving towards something that's predictable, standardized, has benefits for everybody, right? We need to be able to monitor and maintain things like developing these alternative technologies certainly have their place. But again, the creation of standards makes things like environmental impact statements much easier to put together. So where do we go from here? This is the last one, and that is, I see an opportunity for us to integrate the need for seismic and other acoustic data that we all appreciate with a standardized set of tools to monitor and to mitigate and manage those. It gives us a consistent structure for everybody to operate in. And I know from working with the industry for many years off Sakhalin, predictability is a really good thing because it allows them to plan how they're going to execute these things. And that's it. A couple of acknowledgements again for Christina, certainly to Lily for putting together the online live thing. So thanks. No, I agree with the questions about propagation models, and absolutely, and we could spend a long time on that, but that's why I've just presented those as tools. They need to be refined, but the JASCO tool, for example, showed a lot of that asymmetry in those propagation models. You got one in the middle.
indicated after a certain period of time, the animal could sound. Have you looked at the animals to see whether
Those so questions about whether that animal is able to hear those pulses or not. That's based on about I want to several tens of thousands of detections of bowheads. So that's about 15 years worth of data, all compiled into that, and tens of thousands of received bowhead calls. So that was a big set.
I think that's all I have.
Great.
Thank you.
Thank you.